All right. So now you have this motorcycle guy. He's doing this like, woo, projectile type 2. Goes up and down and sideways. All right. So draw a simple diagram of the angle of the motorcycle launch and label its components. So it's kind of going like this. So here's your launch angle for a few seconds. That way, right? And then I got to do the X and Y axis, right? Here's your X, and then here's your Y. So this is going to be your V initial X. And this will be your right here, your V initial in the Y. And your angle is 52. Yeah, that could make it bigger. X component, Y component, this is 52. This is going to be V initial X. This will be V initial Y. You see that? And what's the velocity going straight, diagonally up, not straight up, diagonally up, is 33 meters per second. Okie dokie. There's my quick diagram. Now I'll start labeling our parts. I hate that glare. Darn it. Oh, that's a little better. All right. So it never accelerates horizontally. It accelerates due to gravity. When it goes up, it slows it down. When it goes up, it goes slower, 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 and then it falls back down to the earth. And that's all because gravity influences in the negative direction. Oh, squared. Meters per second squared. Now what other things do we know? Well, we know these velocities, sort of. So you got to do some trickery here. So the V initial in the X axis is going to be your full 33. Hopefully you watch the other video to explain why this is going to be the cosine of that angle 52. Put that in. 33, the partial of 30. It's not the full 33, the partial of it. What partial? Cosine 52. That gives me the adjacent side, and I'm going to round to the tenth. So 20.3. It's going to be difficult when I put that meters per second in there. Now the final velocity in just the component form is always the same. It's always the same arrow length, even right when it hits. So if right here is 20 meters per second, it's 20 meters per second the whole time. So this is 20 meters, 20.3. The whole time. It never changes. So this is the same. Remains the same. Remains same. Remains the same throughout the flight. Throughout the flight. I don't know, he's not really flying, but he might as well be because he's doing this like. All right. What else do we know? Well, we know the component in the y-axis, so the part that makes it go up. This. This is your full 33 meters per second with the partial part, the up part, the opposite part. So that's the sine of 52. Put that in my calculator. Just go back, put sine in there. 26. Oh, that's a nice number. Sounds right. 26. I'm going to put my meters per second. Meters per second. Now, here's the trick. We're only going to study it right to here. That's why I have it broken into halves. Now we're going to look at this part. Notice I go up, and then I go down. So at the max height point, the max height point. What do you know? The max height that's a 0. So going up, V final in the y-axis will be 0. 0. And then when it falls back down, it's going to be falling back down to there. So that's 0. That's actually pretty incredible that somebody figured all that stuff out. Smarter than me. Woo. Now, what do you know? There's symmetry. I don't know if I can spell that word. Oh, it's probably a Y. There you go. Go to your English classes. Be a better speller than me. So the symmetry, if it goes up at 26 meters per second, it's going to go down at negative 26. No meters per second. I can put points there to be a little clearer. Okay, so there you go. Up, go down. Same numbers. Now the time going up will be equal to the time going down, but I don't know that. But I do know things like happy note, find 3 things. There are 3 things in this x-axis, but they don't do anything. They load because this is always 0. 0, 0, and 0. Whew! Here we go. Rock and rollin'. Happy note, found 3 things. 1, 2, 3. So now what do I do? Well, let's solve for the max height and the distance. All right, so I get my reference table. These are the 3 equations we're looking at. We just did the component parts of your velocities. Remember, these A's could be, these vectors could be velocities. So the component in the Y is the full velocity, which was the 33. The partial part, which is sine, in that angle, which was 52. That's where I got that from. Same thing with the cosine. So the Y part of the full velocity is right here. All right, so now I got to figure out, I got to solve for T and D. Well, let's do the first one, might be easier. So let's solve for time. So I choose this one. There's no D in it, so I'm good. I know those are initial and final velocity, and that works great because of gravity. I mean, it's like everybody falls to the earth at the same rate, and there's no air resistance, and that's what we're studying. So I write down V final equals V initial plus AT. V final, well, that's the max height. So right at that top part, in the y-axis, that's going to be, so I put y-axis just to be clear, in case you're not listening and just watching. It's going to be 0 equals 26 plus negative 9.8 t. Subtract 26 from both sides. So you get negative 26 over here equals negative 9.8 t. Divide by 9.8. Divide by 9.8. Those cancel out. Not a lot of room for you guys to see. 26. Let's clear it. 26 divided by 9.8. Time is in seconds. Yeah, that's going to be kind of tough because that's 60. Should I round up or down? That's going to make like annoying things for you guys to do. So I got to choose something here. I said on the other side. What did I say? Did I say it's the hundreds? Nah, I'm going to keep it. I'm going to keep all that. If you round to 2.7, that's good. Don't, and if you did 2.6, it's going to be annoying for me. So I'm going to make sure I tell you guys where I want you to round it. But I'm going to keep the time as 2.65 seconds. I mean, really, I'm not going to notice much time going up. So 2 seconds to go up. I don't know how realistic that is, but whatever. 2 seconds to go up. 1001, 1002. All right. Pops back down. All right. So now I'm going to put 2.65 seconds up. 2.65 seconds down. Total time. Add that up. So 2.65 times 2. Or I'll just do showing you adding. Just to be clear. 5.3. I'll put 0 just to be, clear. I added those two up. Seconds. Total flight time. That means that going up, that going down is 5.3. So that's how much time he was in the air. So I went up at 2, down at 2. Woo! I'm almost done. So once you have the y going up, this height, your dy, max height. That's your dy, that max height, and you're almost done. All right, so which one has the dy? Well, let's get this over here. Dy. Well, I like this one or that one. That might be annoying, but it'll work. Oh, this one's more simple. I guess I could do it for both. So d on the y-axis would be v initial in the y, t, plus 1/2 a t squared. So I'm going to do both because they're kind of a little complicated here. This is the y-axis. So dy is going to be 26 times 2.65 plus 1/2 negative 9.8 times 2.65 square it. Multiply the first two stuff together. There. 26 times 2.65. What's that? 68.9 plus, and I'm going to put this in the calculator. I already know this part's going to be negative, but I'm going to put it at the end. I didn't put this stuff in the calculator. I'm going to put 0.5, that's my half, times 9.8 times 2.65, and I square it. Now this is 34.4. 4 less, jump the mess, so the one's going to go down. Dy. And now I'm going to go that. And there's some symmetries. There's like that's half of that. So without gravity, I would have gone that total height, I guess. And, that many seconds. But because I had gravity, I have to subtract a piece from it. So I had 68.9 minus 34.4. Oh, it's almost the same number. So there's a little bit of rounding. Because of rounding, it's not identical. Because like this would have been easier if that was like a 9. Right, I guess. So dy. Okay, but it's almost half. It should be. Should be half. But there's rounding. But we rounded. So it's almost half, but it should be half. That's what half is going to be. It's almost half, but it should be half, but we rounded. All right. Now I can start putting my information in. You went up at 34.5 meters. You went down at 34.5 meters. So you went up 35. So this y is 35, and then you went down 35 again. Now the last thing we got to fill out in the chart is the dx. So now I'm looking at the x-axis. X-axis. I can't spell. So D, the only useful equation over here, because these are all zeros, because it's not accelerating going horizontally, you have V initial X, T. Well, I know my T, that's the total time, and we got to add those up, double the time. And there's your velocity component, which never changes. So I'm going to do 20.3 times 5.3. My unit for 20 times 20.3 times 5.3. Went around 5 or more, up the score, so it's going to be 107.6. meters. That's the range, 107.6 meters. So he jumped a football length. He went, this, oh, you can't see. This is that number. You know, like a football length. Okay, so what is the range of the motorcycle? There's that one. 107.6 meters. How high does a motorcycle go, though? That's the height. 34.5 meters. All right. There you go. Oof.